Welcome students, welcome to another session of All Fours e-learning program. In the previous topic, we have studied about the relations between different scales of temperature, and I have explained conversion of temperature from one scale to another scales. And now let us talk about different scales of temperature. And after that we will do some more numericals also related to the scales of temperature. First of all, let us know what is a thermometer. Thermometer is an instrument used to measure the temperature. Regarding when you are studying about the measurement of temperature, we have discussed about different thermometric properties. Thermometric properties. As we explained in the previous classes, temperature cannot be measured directly. So, how to measure the temperature? Then we explained that temperature can be measured by the measuring the effect produced by temperature. What are the effects? We have discussed about expansion of liquids and solids or gases, variation of resistance, variation of thermo EMF, variation of EMF, and measuring the intensity of radiation coming from a body. Like this, we have different methods of measuring the temperature. Now, what are using those different methods, we can have different types of thermometers. So first let us discuss about different types of thermometers. First of all, we will have liquid thermometers. Liquid thermometers. What are the liquid thermometers? These are thermometers which are used to measure the temperature based on the principle that volume of a liquid changes with the temperature of the liquid. That means when you increase the temperature of the liquid, volume will also be changing, or there will be expansion in the volume of the liquid. Because of expansion in the volume of the liquid, there will be a rise of liquid level in any capillary tube that we have studied previously when we are discussing about different scales of temperature. So we take a liquid in a narrow capillary tube, and as the temperature is increasing, volume of the liquid will be increasing, and as a result, level of the liquid column in a capillary tube of fixed or uniform cross section will be going on increasing. Best example is the clinical thermometer, which is used to measure the temperature of our body when we get a fever. So that is liquid thermometers. In liquid thermometers, generally we use mercury to measure the temperature of the body. Why we have preferred mercury as a thermometric property, we have explained clearly. Whatever properties are required for a thermometric liquid, all the properties are associated with mercury. So such a thermometer is known as mercury thermometer, and mercury thermometer we can use to measure up to over a wide range about minus 50 degrees centigrade to normally around 350 degrees centigrade. Remember, these are not fixed values. Depending upon the conditions, it represents only a range. It will be around minus 50 degrees centigrade to 350 degrees centigrade you can measure. And sometimes by using some nitrogen gas kept above the mercury, we can increase the range up to 600 degrees centigrade also. So overall, by using a mercury thermometer, we can measure from around minus 50 degrees centigrade to 600 degrees centigrade. We can understand like that. And coming to other one, we can also use alcohols to measure the temperature, which are known as alcohol thermometers. Alcohol thermometers, as we said, alcohols are easily they can evaporate. So you cannot measure higher temperatures using these alcohols, but around from minus 100 degrees centigrade to around some 60 or 70 degrees centigrade, we can measure using this alcohol thermometers. But remember, alcohol thermometers are preferable to measure the low temperatures. Here we can measure around minus 50 like that, or minus 40 like this. But here you can measure up to minus 100 degrees centigrade. That is the advantage. That means when you are using liquid thermometers, this is preferable to measure the low temperatures, and mercury thermometer is preferable to measure high temperatures. Suppose you want to measure around 100 degrees centigrade, this is not suitable because at 100 degrees centigrade alcohols are totally evaporated, but mercury thermometer will help us. So depending upon the temperature we are measuring, we can choose the thermometer which is suitable. So here in liquid thermometers, the basic concept is expansion of volume of mercury with temperature or alcohol with temperature. So change in the volume of the liquid with the temperature we are using here. And next we can use gas thermometers. Gas thermometers. What are the gas thermometers? Very clearly here we are using the principle of expansion of the gases with the temperature. As we said, we can measure the temperature only by measuring the effect of temperature. So here what we consider, here there will be expansion of pressure, right? Variation of pressure of a fixed mass of the gas with the temperature we can use here. With the temperature, the pressure variations. And to study this, we keep the volume of the gas as a constant. So at constant volume for a given mass of the gas, pressure is always directly proportional to the temperature. So there is a proportionality between temperature of the gas and pressure of the gas when volume is maintained as a constant. So that variation of pressure we can use to measure the temperature in case of gas thermometers. Now, when compared with the liquid thermometers, gas thermometers are having some advantages. The advantages is that we can use the gas thermometers to measure very low temperatures around minus 200 degrees centigrade to up to a high temperature around 1600 degrees centigrade also. So range is very high, ranging from minus 200 degrees centigrade or sometimes minus 250 like this, depending upon the gas you are using, up to 1600 degrees centigrade also we can prefer these gas thermometers. So range of gas thermometers is very wide when compared with liquid thermometers. But there is a disadvantage with the gas thermometers. Practically, when compared with the liquid thermometers, gas thermometers are more sensitive, more easily you can measure. The reason is, when compared with the liquids, expansions are more in case of gases. If you consider the expansions of materials with respect to temperature, expansion is least in case of solids and highest in case of gases. So as the expansion of gas is very high, the sensitivity will be very high. You measure very accurately by using the gas thermometers. And range is also very wide. And the sensitivity is very high. Sensitivity is also very high with this gas thermometers. That means you can measure very accurately. But there are two important disadvantages with gas thermometers. What are the disadvantages? Number one, these gas thermometers are not portable. These are not portable. If it is a liquid thermometer made up of mercury, just you can place in your pocket and you can go anywhere, wherever you want to measure the temperature. It is portable. But gas thermometers are very big in size. They are very big in size and they are not portable. You cannot take from one place to another place to measure the temperature. So that is one disadvantage. Number two, there is one more disadvantage, that is that they are not direct reading instruments. They are not direct reading instruments. That means if you consider the mercury thermometer, suppose we go to a doctor with fever, he will place a thermometer and after that taking out, he will give the reading directly. So directly you can measure the temperature with liquid thermometers, but it is not the case with gas thermometers. In gas thermometers, the second disadvantage is that it is not a direct reading instrument, because when you are measuring the pressure variation with respect to temperature, we have to do some calculations to estimate the temperature. So that's why as we need some calculations to get the value of the temperature, it is not direct reading instrument. That is one disadvantage with these gas thermometers. So let us just revise those points. Advantages are that the range is very high and it is more sensitive. Otherwise more accurately we can measure the temperature. But the disadvantages are more important here. The instrument is not portable. You cannot take from one place to another place. And number two, it is not a direct reading instrument, because simply by taking out you cannot measure the temperature. It requires a laborious calculation to get the final value of temperature. So generally it is not used in day-to-day life to measure the temperature. But because it is very sensitive and very accurately we can measure the temperature using gas thermometers, they can be used to compare the results obtained by other thermometers. That means you can standardize. You can standardize other types of thermometers by using gas thermometer. That is the advantage of these gas thermometers. Right. So after the liquids and gas thermometers, let us move on to the next type, that is resistance thermometers. Resistance thermometers. That is the third category. Resistance thermometers. What are these resistance thermometers? For every material there is some electrical resistance. Resistance means an opposition for the flow of current through the conductor. Every material they have some amount of resistance, and this resistance is a function of temperature. Resistance of any conductor is a function of temperature. So by using this principle, resistance changes with temperature. So by using this condition, we can measure the temperature of a body. So variation of resistance. Different materials will have different variations. So by the requirement of the temperature range we want, we can use different types of resistances. But in overall, we can say that around from minus 200 degrees centigrade to around 1200 degrees centigrade, up to this range, we can use these resistance thermometers. Especially platinum wire resistance thermometer is generally widely used in this resistance thermometers. Right? So this is about resistance thermometers. Basic principle you have to remember: the resistance of a conductor will be varying with temperature. That is the basic principle. Now, after resistance thermometers, let us talk about thermoelectric thermometers. Thermoelectric thermometers. What are these thermoelectric? As we have explained during this topic of thermometers previously, when we take a metallic, two metallic wires combined with each other to form two junctions like this. Suppose one is copper wire, another is iron wire. At the two junctions where copper and iron are meeting here, a temperature difference is maintained. Suppose you want to you want to measure the temperature of a body. Keep one junction in contact with that body and keep the other junction at some temperature like 0 degrees centigrade. Then there will be a temperature difference created. Because of this temperature difference, an EMF is generated. By knowing the EMF, that is called thermo EMF. Thermo EMF. That means electromotive force created because of the temperature difference. By knowing the value of EMF, we can estimate the temperature of the body. So this is the basic principle. So variation of thermo EMF with temperature is the principle involved in the measurement of temperature using this thermoelectric thermometers. And here also the range is very high, around some minus some 200 degrees centigrade or minus 150 degrees centigrade, up to a large temperature around 500-600 degrees centigrade also we can use these thermoelectric thermometers. But the importance of these thermometers is these junctions can be prepared. These junctions can be prepared in very small size. By a minute size also we can prepare the junctions. So because of that minute size, they can be used to study the temperature of the bodies of small insects. They can be used to measure the temperature of body of small insects also. Because of the small size, you can measure the temperature of the small insects also. That is the advantage. Number two, these junctions will have large thermal capacity. Easily they can take energy. So because of this reason, they can also be used to measure the temperatures which are varying very fast. When the temperature is changing continuously, that varying temperatures can be measured more accurately using these thermoelectric thermometers. So there are 3 points you have to remember. Number one, the principle involved in the measurement of temperature is variation of thermo EMF with temperature. The advantage is that the range is very high, from minus 150, 200 to around 800 degrees centigrade, like that you can measure depending upon the temperature. And another important thing is they can be used to measure the temperature of even small insects because they can be made up of very small in size, minute size. Number two, because of the large thermal conductivity of these junctions, they are made up of metals. So thermal conductivity is very high. As a result, they can be used to measure constantly varying or quickly varying temperatures. That is the advantage of these thermoelectric thermometers. Now, after thermoelectric thermometers, let us move on to another type of thermometers which are called radiation pyrometers. Radiation pyrometers. What are the radiation pyrometers? They are also thermometers practically, but of course they are also not direct reading instruments. They are also not direct reading instruments. They can be converted into direct reading instruments by some mechanism. But the basic principle involved is whenever there is a hot body, it emits thermal radiation. According to the law known as Stephan's law that we will be studying after some time, the energy radiated from a hot body is directly proportional to fourth power of temperature of the body. The energy radiated from a body is directly proportional to fourth power of temperature of that body. That means when the temperature is very high, it emits more amount of energy. So based on this principle, we can measure the temperature in case of very hot bodies like the furnaces in an industry. Because if you consider the chemical industries, the boilers or the furnaces in a metallurgical industry, the temperature is very high, some thousands of degrees centigrade, and nobody can measure the temperature in such a case because we cannot place a thermometer there to measure the temperature. When thousands of temperature is there, the only method to can measure the temperature is by measuring the radiation coming from the body, and then we use these radiation pyrometers. So they can be used to measure the temperature of the stars. By taking the energy coming from the sun or coming from the stars, we can estimate the temperature of the sun and the stars also by using radiation pyrometers. The temperature of the sun is estimated to be around 6000 Kelvin by using radiation pyrometers only. So very high temperatures they can be measured by using radiation pyrometers. Of all types of thermometers we have studied so far, these are the instruments whose highest temperature, the measurable temperature is very high. But you can use these pyrometers only when the temperature of the body is around 600 to 800 degrees centigrade. The temperatures below this, they cannot be measured accurately, because when the temperature is very small or less than a minimum value, energy radiated from the body is also less. Then you cannot detect. To detect the energy coming from a body, it should have some minimum value. That is possible only when the temperature is also having a minimum value. That means when the temperature is minimum around 6 to 800 degrees centigrade, the energy coming from that body we can measure, and from that we can estimate the temperature of the body. But basically radiation pyrometers are used to measure the temperature of astronomical objects. Astronomical objects in space study or astronomy, and in day-to-day life in our factories or the metallurgical industries, to measure the high temperature furnaces, we use these radiation parameters. So this is about the different types of thermometers and their different ranges, their applications and limitations. Now, after discussing about the limitations, the different types of thermometers, their applications and limitations of use, let us move on to some numericals. Some numericals based on the equation that we have studied in the morning session or in the previous session. Here, the relation between different scales of temperature we have given as C in centigrade scale. We have given a factor that in any temperature, in any scale of temperature, if the reading of given by thermometer is X, then X minus LFP divided by UFP minus LFP, it remains as a constant. This principle we can use for different scales. Then we got the relation by applying for the centigrade scale, Fahrenheit scale and Reamer scale. F minus 32 by 9, C by 5 equal to F minus 32 by 9, that equal to R by 4. We can use like this. Now, to convert, let us go ahead with some numericals related to this problem, this formulae. Let us consider a case, the temperature, I am measuring the temperature of a body. When I am using a thermometer made in centigrade scale and another one which is graduated in Fahrenheit scale. I am measuring the temperature of a body using a centigrade thermometer and a Fahrenheit thermometer also, let us suppose. And suppose both of them give same reading. Then what should be the temperature of the body? That means it is the temperature at which both the centigrade thermometer and Fahrenheit thermometer will give the same reading. Let us calculate the temperature. We are talking about equivalence of Fahrenheit scale and centigrade scale. Both are giving the same reading. That means the reading in centigrade scale and Fahrenheit scale, let us say each is equal to some theta. Theta is the temperature in both the scales. Then very clearly C by 5 or theta by 5, that is F minus 32. In place of F also let us write theta minus 32 by 9. So theta by 5 equal to theta minus 32 by 9. Then let us find out the value here. By cross multiplication we will have 9 theta is 5 theta minus 160. Otherwise taking 5 theta here, 4 theta is minus 160. Otherwise theta equal to minus 40. That means when the temperature of the body is minus 40, the centigrade scale thermometer and a Fahrenheit thermometer, both of them will give the same reading. So this is one important point, or one important numerical we can understand for the equivalence of the scales. Now let us suppose, can we have a temperature where the centigrade scale and Reamer scale will give the same reading? Here we are considering a case where centigrade thermometer and Fahrenheit thermometer both are giving the same reading, and that is taking place at a temperature minus 40. That means minus 40 degrees centigrade or minus 40 degree Fahrenheit, both are one and the same. Now let us verify the case, centigrade thermometer and Reamer thermometer, suppose they give the same reading. Let us verify. To equate, if both of them give the same reading, because theta will be the same. So in centigrade scale and Reamer scale, let us say theta is the reading. Then equating these two, theta by 5 must be equal to theta by 4. Theta by 5 must be equal to theta by 4. Very clearly this is not possible. That means in any case, for any body of any temperature, there is no possibility that the centigrade thermometer and Reamer thermometer will produce same reading. That is never possible. Now let us look at a temperature where Fahrenheit scale and Reamer scale can produce same reading. Let us verify. Suppose the reading in the Fahrenheit thermometer and Reamer thermometer each is equal to theta. So let us equate these two terms. So theta minus 32 by 9, that will be equal to theta by 4. We are equating these two. In Fahrenheit scale and Reaumur scale also, the temperature theta is the same. That implies by cross multiplication we will have 4 theta minus 128, that will be equal to 9 theta. Then what you will get here? Taking to the side here, 9 theta minus 4 theta. Otherwise 5 theta is minus 128. So theta equal to minus 128 by 5. We can find out. It is around 25.6 with the minus sign. So at this temperature, minus 25.6, that is the temperature at which the Fahrenheit thermometer and Reaumur thermometer, both of them will give the same reading. So like this we can find out the temperatures which are equal in both the scales, whether it is centigrade Fahrenheit or Fahrenheit Reaumur, we can find out. Now let us consider another possible case. In the previous class we have studied about variation of temperature, that is delta C by 5 equal to delta F by 9, that equal to delta R by 4. When the change in temperature we are talking about, for a delta C, change in temperature corresponding to centigrade scale, we can find out the corresponding change of temperature in Fahrenheit scale. Let us have a small example. Suppose the temperature of a body is increased by 20 degrees centigrade. Then correspondingly what will be the change in Fahrenheit scale? Let us apply the principle. So delta C by 5. So 20 by 5 will be equal to delta F by 9, or you will get delta F equal to, that is 4 into 9, 36 degrees Fahrenheit. So when temperature is increased by 20 degrees centigrade, in Fahrenheit scale the change in temperature will be around 36 degrees centigrade. So these changes we can find out. And one more thing, let us go on to another problem where there is a faulty thermometer. Faulty thermometer. In case of faulty thermometers, how to solve the problem? Let us have a small example. There is a thermometer which is graduated in centigrade scale, but the lower fixed point is wrongly noted as 20 degrees centigrade and upper fixed point is noted as 90 degrees centigrade. Actually in centigrade scale we know lower fixed point is 0 and higher fixed point is 100, but it is a faulty thermometer where the gradations are wrong. But the lower fixed point corresponds to 20, upper fixed point corresponds to 90. And suppose this instrument gives a reading at about 60 degrees centigrade. This is the reading given by this faulty thermometer. Now, what should be the correct reading, correct temperature of the body in centigrade scale? This is a faulty thermometer. Now, I want the correct reading in centigrade of the temperature of the body in centigrade scale. Then what we have to do? Remember, in any thermometer, in any scale of temperature, you can use the equation x minus LFP by UFP minus LFP. This remains as a constant. In all these problems like this, we can use this relation. In the given thermometer, the temperature given is 60. And what is lower fixed point here? Lower fixed point is the melting point of water. That is faultily recorded as 20. So it is 60 minus 20 and UFP minus LFP. This is 90, this is 60. So the difference is 70. So 60 minus 20, that is temperature given in the scale is 60, that is X, minus LFP, LFP is 20. UFP minus LFP, in the faulty thermometer or in the thermometer given which is wrong, UFP is 790 and LFP is 20. So the difference is 70. Now let us equate this with our accurate thermometer which is graduated in centigrade scale. When you are using the centigrade thermometer which is to be considered to be correct, the theta, let us say the temperature is given is theta and LFP is 0 and UFP is 100 minus LFP is again 0, so that this becomes 40 by 60 minus 20, 40 by 70, or you can say 44 by 7, that will be equal to theta by 100. So we can find out the correct value of theta from the equation that 7 theta equal to 400 or theta equal to 400 by 7 degrees centigrade, which we can measure accurately. So like this we can use the principle, this equation we can use to measure the temperature of a correct temperature of a body in centigrade scale when a reading is given by a faulty thermometer. The faulty thermometer is giving a reading 60 degrees centigrade, but what is the correct reading given by thermometer is 400 by 7, and this is more accurate. So we are using the principle, this equation, applying for faulty thermometer and for the true thermometer or correct thermometer which is graduate in centigrade scale. Suppose the same thing if you want in Fahrenheit scale also you can apply, right? But all the readings must be in Fahrenheit scale. So these are some examples related to this topic. Now with this topic let us stop here, and in the next class we will discuss about the next topic and practice all these numericals once again. Practice all these numericals once again, and let us stop here.